Behind the beauty of the candle, there is chemistry.
Have you ever wondered how a candle emits light? Is it the wick? Or is it the white paraffin wax that makes it burn? Welcome to the new episodes of Your Chemistry Guide. Today, we are going to explore the chemical reactions of burning candle through macro, micro, and symbolic world of representations.
Dad, can you bring me some light, please?
Welcome to the macro world.
A candle is made up of a wick and a wax. Paraffin wax is essentially hydrocarbon, which is largely composed of carbon and hydrogen atoms, and these serves as the fuel of the candle. When you light a candle, a combustion reaction begins in which a hydrocarbon reacts with the oxygen in the air to form water vapor, carbon dioxide, and energy in the form of heat and light. The heat of the flame melts the wax near the wick and creates a shallow hole for the liquid wax. And with the presence of oxygen, the flame would vaporize the wax molecules and start to break down the hydrocarbons into the molecules of hydrogen and carbon. Surprisingly, because the wax vapor is still flammable, we can quickly relight the candle by introducing a flame above without actually touching the wick. The candle undergoes both physical and chemical changes. When you light a candle, you will end up with less wax after burning. This is because the wax oxidizes to yield water and carbon dioxide. And aside from combustion, burning of candles is one example of redox reaction. Here, the hydrocarbon acts as the reducing agent, while the oxygen is the oxidizing agent.
Welcome to micro world.
Candle waxes are made of hydrocarbons, meaning they are largely composed of hydrogen and carbon atoms. When a candle is lit, you can observe zones. In the oxygen-rich blue zone, hydrocarbon molecules vaporize and start to break apart into hydrogen and carbon atoms. The hydrogen is the first to separate here and reacts with the oxygen to form water vapor. Some of the carbon burns here to form carbon dioxide, meaning the hydrocarbon is reduced as it loses its electrons but gains oxygen, whereas the oxygen atom is reduced but gains electrons. The dark or orange-brown region has relatively little oxygen. This is where the various forms of carbon continue to break down and small, hardened carbon particles start to form. As they rise along with the water vapor and carbon dioxide created in the blue zone, they are heated to approximately 1,000 degrees centigrade. At the bottom of the yellow zone, the formation of the carbon particles increases. As they rise, they continue to heat and emit the full spectrum of visible light.
Welcome to symbolic world.
To understand the redox reaction, we need to look at the chemical equation. The chemical formula for paraffin wax is C25H52 reacts with oxygen to produce carbon dioxide and water. Now let's dive deeper into the redox part of this reaction. First, let us balance our chemical equation. So in order to balance our carbon atoms, we need to add 25 here in our product. In order also to balance our hydrogen atoms, which is 52 in our reactant, so we need to add 26 here in our product. 26 times 2 is 52. Now we are going to balance our oxygen atoms because in our product we have 76 oxygen atoms. 25 times 2 is 50 plus 26 is 76. So we need to add 38 here in our reactant. So now that our chemical equation is already balanced, we are going to assign charges for each atom. So carbon will be having a 0 charge. It means it is in the neutral state, as well as in hydrogen and oxygen. And in our product, the carbon will be having a positive 4 charge, and our oxygen will be in negative 2 charge. So our carbon atoms in paraffin wax are being oxidized. So they lose electrons, transitions from a neutral state to a positively charged state, with each carbon atom having a positive 4 charge when forming carbon dioxide. So this is the oxidation. So next is our oxygen atoms from the oxygen molecule are being reduced. So they gain electrons during the reaction, changing from a neutral state to a negatively charged state, with each oxygen carrying a negative 2 charge when forming the water. So this transfer of electrons is what makes it a redox reaction.
Redox reactions plays an important part in our lives. Combustion reactions such as burning of natural gas, wax, oil, gasoline, and wood are all redox reactions, which provide some of our most basic needs: the heat, light, and transportations. Ultimately, the significance of comprehending redox reactions transcends scientific understanding, influencing our energy sources, the environment, and our overall quality of life.